Let's continue with our handout. So we have seen how we have changed the member variable to be a pointer inside the rectangle structure. And of course we made changes accordingly to our constructor. So we did make updates to our constructor. So our constructors have been changed to reflect the new version of the structure name, which is now a pointer. So these changes are already in place. Of course, what we could do also is we could realize that when you have member variables, and as in the future we'll try to make them private when we switch from structures to classes, by default member variables will be kept private inside our structure definitions. But for now, it's just an idea that just like we already added this setName function to the declaration of our structure, likewise we can have a getName, and it's another function that we can have, and functions that basically manipulate individual member variables of our objects are called setters and getters. So these are just examples of setter and getter for the name of our rectangle structure. So of course these are examples of using this new function getName. So if we add this function getName to our declaration of the rectangle, we can of course call getName and see what the names, we just print this name, and it's pretty trivial. So perhaps we can do this just to keep up with this presentation. Right, so we can add so this will be our definition, which of course belongs to the rectangle implementation file .cpp, and not to forget that we need to use the proper scope resolution with this. So that should be all we need to do. Just return from this function getName, just return this pointer back to the caller. That's all we need to provide access to this pointer. But of course we also need to copy this signature of the function and create a declaration inside our structure, and it's actually the opposite of what we do in the implementation. Here scope resolution inside the rectangle is not allowed. This will give you another error message. In fact, we can try building it with this type of thing, and says illegal qualified name in member declaration. Okay, so this here brings us to illegal qualified name. So this fully qualified name should not appear like this, but rather just a simple member function of the structure. So here we don't need this, and now we can build it again and it should be fine. We're still missing semicolon somewhere. Yeah, I forgot the semicolon to add to our member declaration. So that looks good. Okay, and so now I just want to keep up with the handout. So with this in mind, let's proceed to the next level of experimentation with our rectangle structure. And this time we're going to try to use some dynamic memory allocation. So what does it mean? It means that anytime we'll be constructing a rectangle, and let's switch over to our examples of instantiating our rectangles. So anytime we have a rectangle, what we would like to have, like we create this unit rectangle, right? So this unit rectangle we create, and it's going to be a rectangle object in memory. Then we create this rectangle right here called rect, and it's going to be another object in memory, which is the same, but another object. And then we also make a copy right here, and so this will be also new rectangle. And then what we'd like to do with these three copies that we have so far in our main function example, we said that any time the name of the rectangle is provided to us, what we'd like to do, instead of just storing a pointer to this original string of characters, what we would like to do instead, we would like to have this rectangle, this object. In fact, it will be the constructor of this object, that we would like to make a copy of the string dynamically. So this string exists in somewhere in computer memory. This is read-only string. But we don't want this rectangle object to attach its pointer to this string. Instead, we'd like to make a copy of it dynamically, right? So this string right here will be brand new string, copy of the original, and we'd like to have this object, rectangle, storing a pointer to this copy. Also, likewise, when we create a copy of an existing object, what we'd like to do in this case, instead of just making an object with its own pointer that would be pointing to the same string, we also, like part of making a copy of the original rectangle and constructing this rectangle 2, right? So this is rectangle 2. What we'd like to do, we also would like to take care of this dynamically allocated memory, and we want to make a copy of it as well, right? So somewhere there will be, so this will be copied over here, and the new object, part of manufacturing a copy, will be pointing to its own unique version of the string, right? So this is the idea. So this is called a deep copy or complete copy of the original object. So this will be part of our discussion to demonstrate how we can handle allocation of dynamic memory. Now again, I'd like to note that this sounds like a complicated business, and it is a low level. We will just do some experimentation, but all of it can be spared, and you don't have to worry about any of this if instead of doing this dynamic memory allocation, you simply change to use the string, right? So the original idea of using a string object which manages this memory automatically for you is a perfect idea that would let you avoid a lot of this lengthy exercise in managing dynamic memory. But we're going to do this for an exercise to introduce how dynamic memory can be managed. But in the end, at the end of this presentation, we'll probably switch back to the string version of the rectangle that wants to have its own name. So this is just a little messy preview of what we're about to do with the code, so let's get started.